Our first speaker is Yuri Malkov. He's a member of the technical staff, a research scientist at OpenAI. He's the creator of HNSW Vector Index. So if you are in the world of vector databases, that's a very big deal. This is an essential index for any modern vector database. Previously, he was a board of advisors at Pinecone. He's also currently steering committee for Milvus, and he's worked on recommender systems in Twitter and Verse Innovations. He's going to speak about approximate nearest neighbors search in recommender systems. Welcome, Yuri.
Yeah. Oh. Okay. Can you hear me? Yeah, my name is Yuri Malkov. I'm going to talk about approximate nearest neighbor search for recommender systems in particular. So yeah, about me, I'm a PhD in laser physics. But I worked in computer vision, like NLP. Also, I did similarity search and recommender systems. So I'm currently employed by OpenAI, though this talk is going to be about recommender systems. Well, finally, approximate nearest neighbor search become mainstream. So like I have been working on that since 2007. And yeah, right now, like right up to the moment, quite recent moment, so it wasn't that big of a deal, but now it is has a lot of traction. So, and basically, approximate nearest neighbor search is a problem of efficient search of a closest points from a set of points given a query, and it's based on a specified distance. So there are many matured methods and libraries that do approximate nearest neighbor search. So that is one HNSW, but there are other solutions like DiskKNN or like its modifications. And there are many mature solutions, some graph-based, some inverted index-based, and there are good benchmarks for those methods. So for vanilla methods, like ANN benchmark is a good one. And while it's a good benchmark for vanilla nearest neighbor search, it has some limitations from practical standpoint. So if you actually use it in a recommender systems, so it might not be great for you. And yeah, what are the applications of the nearest neighbor search? So first of all, it's a recommender system. So, and the typical goal here is to recommend an item for a user. For instance, it can be search, home timeline, or notification of a typical social network. So it is a big business with a lot of revenue, but there are issues with generalizability and reproducibility of the solutions. So it's very hard to generalize from one company to another due to reliance on custom data. It also has huge corpus, and there can be like trillions of items to rank. And inference cost is very important. So you have a lot of users and a lot of items. So yeah, and they have a multi-stage funnel. And also typically it has a homegrown solutions. Like Meta has its own solutions. Google, Snap, Pinterest, like Verse Innovations, Twitter, they all have like their own solutions for ANN. Another application is large language models. They become very popular quite recently, and they are extremely generalizable, like especially compared to recommender systems. And they are, I think, starting to revolutionize recommender systems because, well, of this generalizability. They have well, and while nearest neighbor search is the essential part of LLM itself when it selects the next token, so there are other things that ANN can solve. And known issues are there is a limited vocabulary, bounded context length, and hallucinations. So LLM can generate something that like wasn't in the training data, so invent something. And it is typically solved by retrieval augmented generation, which is the most popular application for ANN, as far as I know. So it's basically, so you have a question like who is the president of the US. So you retrieve a document which has a good up-to-date answer, like from Wikipedia, which is a trusted source, and you put it into a generator. So together with question and the article from Wikipedia, you can say, okay, that is Joe Biden, like I know for sure. It is grounded, and it's simple. Yeah, so but that is also like a kind of recommender systems. And typical retrieval augmented text retrieval setup also has stages. So it has retrieval, there is some re-ranking, and another ranking is done implicitly in the generator, because like when you provide several documents from the Wikipedia, so like it selects like which of them to use and which of them not to use. And yeah, so I'm going into tighter integration between those. So going back again, so what are the features of large-scale recommender systems? First of all, that approximate nearest neighbor search is only a part of a multi-stage design with cascaded models. So like ANN is generates candidates for the system. Then though they have like lightweight ranking, which is brute force with some middle model. Then there is a heavy ranker model in the end. And there is some business logic on top. And one of the things that queries and items in recommender systems have a very different nature. So they live in different, incompatible spaces. So, well, you have query, like user features, and you have item features, so like they don't compare. And that is also like a problem which I'm gonna discuss. Yeah, and there are like many items. So like if you have a properly designed machine learning system, so you can say, okay, ranker is the final component that ranks everything. Why we can just apply ANN to the ranker itself? Yeah, and going again, so the queries and documents live in different spaces. So, and you have a nonlinear function, which is the ranker. And while technically you can use HNSW to search with the graph, it's not clear how do you construct the graph for HNSW, because HNSW by itself, it's a graph algorithm. It cares only about the relative distance of the query to like items. So, but here, like, how do you put it? And there are some solutions that were proposed. So like one solution is use just L2 on data vectors, because everything is vectorized before it's put in recommender systems, like the input to the ranker. Well, you have vectors, you can say I have L2 distance between the vectors and have a surrogate for the graph. And it actually works. So you can create a graph and then use your ranker distance, which is a neural function based on those vectors, and it provides a speed up compared to like when you generate candidate and then re-rank. But there are other methods on how to do that. So another method is you can project the items to query space. So you cannot compare items to each other because there is no distance function between them. But because you have queries, you can say, okay, like you select 1,000 queries, calculate the distance between an item and those queries, and say, okay, this is my new space. And then I use like L2 space with those vectors. And it also works well. So like I published a paper on that 10 years ago, then it was rediscovered and have like a much better paper on this, and it works better than the previous approach. And there is an alternative approach with bipartite graph ranking. So like another paper. And here the idea is that, okay, like you have items and they have closest, like a graph of closest users or queries, and you have queries like for which there are some nearest neighbors in the item space. So you have a bipartite graph. And when you generate the graph, you can basically sample from this bipartite graph to generate the edges between the items. It also works well, but there was no direct comparison between those approaches. So I don't really know how do they compare. So I'm curious about that. Another thing that people tried is do graph re-ranking directly with the ranker. So the solution basically, so you have a heavy ranker and you have a graph which is created from vectors, so for candidate generation. So that graph is easy to produce, and then you basically apply the graph on top of it. That is kind of similar to this approach, but it's done for text retrieval, and it's also known to produce good results. So it is increased. And what it does, it basically removes the funnel, because like before that you had a candidate, you had some candidates, then you filter them out with a heavier function and then heavier again. But when you did the approaches like this or this, so you can undo the mistakes that are done at the earlier levels. So because those candidates are only a seed for the graph traversal. Yeah, so basically another idea around that. So yeah, you can even start search using the same graph, which is computed by either a light distance or a heavy distance. And at some point of search, you can just switch the distance function from a fast, lightweight function to a heavy function. So which is basically a runtime, cascaded runtime optimizations. Yeah, so yeah, there was another topic that I wanted to cover is ANN over training and binarization, which is also an optimization for search. So basically, so you can compress embeddings by running PCA or product quantization. Those are popular methods. But there are some interesting compression-aware training methods. So like one of them discussed in Neil Raymer's presentation. So like on YouTube talk. So basically the idea there is that if you want to produce embeddings which are compatible with binarization, so you basically add a loss which converts from basically makes the embedding centered around 0. So and then you can easily binarize them. So another learnable solution is subvector aware training or matryoshka embeddings, which became popular, well, not that long ago. And basically those, just list of prefixes for training the embeddings. And because you have different complexity of representation, so you have full vectors, you have faster compressed vectors, or sub vectors in matryoshka. So you can use them in cascaded ANN. So and there are quite a few works that work in that direction. So also use that. So overall, I wanted to convey that approximate nearest neighbor search and recommender systems is much more integrated into other parts of the stack. So, and that is an interesting field to work in. Yeah, that's all from my part.
Hey, thank you. Are there any questions?
See, when you use the nearest neighbors search solution, will it give you the correct answer? That's what I want to know.
Well, approximate nearest neighbor search solution. So so basically they have in the limit of infinite compute. So they give you the exact solution. So they are made this way.
Thank you.
I was wondering if you could give an example of how my user experience, like give an example of a typical application that I use on an everyday basis, or that the average user uses on an everyday basis, and how their user experience would be substantially changed by applying ANN in terms of their recommendations.
Well, most social networks and search engines use ANN. So if you remove that, so they will work much worse. So
like an example of, like, I'm scrolling through Facebook, I'm looking at things. How would my experience of scrolling through Facebook, looking at things, be different if I apply this algorithm versus whatever they're using currently for their recommendations?
Well, out of network recommendations would be much worse. So like the recommendations that are done within the network, like the people that you follow and like the groups you follow on Facebook, they will be okay. But if you want to explore, so that's gonna be an issue. So that is like, you have a semantic space, the nearest neighbor search in semantic space, like you represent your interest. So that is the typical problem. So in search, like if you search, say in Facebook as well, so it will like you have keyword-based search, it would work, but with embeddings-based, so there is like semantic meaning if you are using like different wording, so it wouldn't find it with keyword search. But with embeddings-based, it can find it.
I think I want to circle around to you, like do a deeper dive on this later on. So thank you for the answer.
Well, yeah. Also, you can RAG setup with LLMs also like a good example. So if you want LLM not to hallucinate, so RAG is a. Well, yes, because it provides grounding for the generations.
I have another question. Is there a difference between k-nearest neighbors and ANN? Or are they the same thing?
Yeah, that's the same thing.
Okay,
so
gotcha. That's all.
I love that you brought up Cohere and Niels. They're now beta testing compression on for the consumers, and they're selling something like 32x, 64x. What do you think the theoretical limit for a reasonable system with 1 million to 1 billion records is?
Well, compression, you mean their latest embeddings are compression trained with compression aware, so you can binarize them.
Yeah.
Well, that is useful, but there are alternatives like product quantization. So, well, it's a good approach. Yes. Yes.
Do you think you can end up with something much more compressed than 32x to 64x, or do you think that'll run into issues?
Well, it already runs into issues. So if you go through to that presentation and look, so there is a loss on performance with that compression, and well, there is a trade-off between compression factor and accuracy. So, well, you can compress more. And with Matryoshka embeddings, you can compress it like from 3K to 4. And there will be some accuracy.
Of course.
Well, first, thank you for your work here and outside. And for those of us that want to get a little deeper, what reading material would you recommend on maybe quantization joined with compression, or where would you go to dive deeper into this and putting into practice for different RAG systems?
Well, for those, like I have references, so we can look.
Yeah, no, of course, but I mean for further other ways to have implemented this into actual libraries that can be tested, or where would you guide somebody that wants to start evaluating different implementations of these approaches?
Well, from open source, if you want a library, so you can look at Face, for instance. So Face has multiple indices implemented. So for compression, so I don't think there is a like one good place if you want to train it. So, but those methods are fairly simple, so you can implement them. Like
yeah. And how would you actually build a way to compare when you're talking about performance at an application level, and you have to build an evaluation framework that will actually take the business success into account? Do you usually, or have you ever work with business stakeholders to define benchmarks that can work for you scientifically, but also for the business in their language?
Well, in recommender systems, there is typically a target metric that you want to optimize. So, and you use that metric. So, like when you do retrieval, so you have a recall at.
Yeah, but there are many other things that nowadays people are looking at for measuring the quality of those systems. Just wanted to know if you had other specific opinions. But in any case, thank you.
Okay, thank you.
Okay, this is the last question.
Thank you, Yuri, for your talk. Just curious about using compressing embeddings with PCA. So in PCA, my understanding is it's about reducing dimensionality. I'm curious, when you're talking about compressing embeddings for the training stage, are you training the compressed versions of the embedding? Are you training, or what's the benefit of compressing these embeddings in the training?
So for Matryoshka, so when you train the embeddings, you have a prefixes. So like you say, okay, like for 8 dimensions, I apply the same loss as for full. And then if you like generate the full embedding, but you say, okay, that is too costly. I cannot work with that. So you just take the prefix, and because it's already trained for that specific loss as you want, so that's going to be pretty close to optimal. So, and it is very similar to PCA, but PCA is unsupervised. So, and here you directly introduce a loss for your target. And for the compression over training, so like if you apply the loss, that basically centers the embedding around 0. So when you binarize it, like it's you have less of an error of approximation. So both of those. So if you select smaller one or binarize, so you'll have higher accuracy, higher target metric if you apply those methods.
I see. So you're saying there's higher accuracy when you use the compressed embedding version? When you
yes,
do these matrix
multiplications? Yes, it's.
I see. So both like space and accuracy increase. Or sorry, your optimized space, but then the accuracy is also better when you train.
Yes. So when you do binarization or reducing the dimensionality, the accuracy is better if you're using learnable methods.
I see. Thank you.
Well, accuracy will take a hit because you reduce the dimensionality, yes. But you can reduce dimensionality by using PCA or using learnable methods. And with learnable methods, it is going to be a less of a hit.
All right, so Yuri's going to be, actually you're headed out. You can send questions if you have them, and we'll get them to him to follow up. So let's thank our speaker.
Yeah.
And our next speakers are Jitin James, CEO, and Shahul S., the co-founders of Exploding Gradients. This is the company behind maintainers of Ragus. And Jitin is an ML engineer. Shahul is a Kaggle grandmaster and AI researcher. And they're going to be speaking about metrics-driven development of RAGs.
Oh, okay. Where's the hand hold? ഈ പ്രശ്നം വന്നോന്ന് പറയുന്നത് എടുക്കണോ മിക്കവാറും ഈ ലാപ്ടോപ്പ് തന്നെ Oh, that is going to be hard. Huh? I guess, yeah. You'll have to set it up. Oh, like it's not taking it up. Yeah. Will what is Jason ready to go? I guess we'll have to cross.
Oh, okay. How about this one? Did this? Oh, do you have another? Oh, you have. What's this one?
Yeah, it's good. Yeah, but awesome. All right, let's hope it's a smooth sailing from here. But yeah, so yeah, my name is Jitin. That is Shahul, and we are going to be, first of all, like, thanks for Christy to like inviting us. This is our first talk here in like SF, so we are pretty excited about that. But yeah, thanks, guys. So today we are going to be talking about metrics-driven development with RAGs. But first of all, like, how many of you like interact with RAGs or like tune it on a day-to-day basis? Okay, cool. Quite a few. Have any of you used Ragas before? No. All right. Hopefully, some people might be interested after this. But yeah. So my name is Jitin. I'm one of the maintainers of Ragas.
I'm Shahul. I'm one of the maintainers of Ragas.
Yeah. Cool. And this is going to be an evolving talk. So all the notebooks, slides, everything will be there in the Exploding Gradients /notes repository. So if you go there, like, we'll keep updating this as we do more experiments. But yeah, the objective. So if you are playing with RAGs on a day-to-day basis, the problem is that like you have a lot of things that you want to test out. You do something, then you have to manually check and evaluate it. And we have been building RAGs for a few months. And and then like we've faced this problem ourselves because there was no effective way of evaluating this, evaluating what we built so that we can test it iteratively. So that's when we came across the metrics-driven development, or it's just a spin-off of trust-driven development. But that's the objective that we want. So we want to show you how we actually use Ragas ourselves to iteratively improve the RAG pipelines that we built. So to build a RAG, we need a test set. We took an old test set called Casper, which is basically an ML paper which a data scientist actually gave a question and an answer. So that is a data set that we'll be using. Specifically, we'll be using not the questions, but the papers themselves of the training distributions. And first step, what the problem was, so we have, thanks to the Casper dataset, we have a set of papers that we'll be making the RAG on top of, but we don't have a data set that we want to validate. So to begin, like metrics development, we want to evaluate it, and for that we needed a test set, and that is why we built test generation piece, which Shahul will explain more.
Yeah. So again, yeah, we needed to our developers, our users who wants to test their RAGs, test their LLM application, they want a test data set to begin with. And the problem is that nobody wants to go and label or create a test data set manually. It's just a boring thing to do. I myself is an ML engineer. I hate doing it. So most of our users wanted something that could synthetically generate a proper test data set that is of high quality and as of diverse nature as possible. Even though LLMs like GPT-4 and all are of high quality, the problem remains that the questions generated out of a naive GPT prompt doesn't really represent a proper test data set or the type of questions that we see in production. So we wanted to come up with an algorithm that could generate a high quality and diverse test data set from any set of documents that you can feed it. So that's the core idea behind synthetic test data generation. And the way we do it is using a concept called question evolution. So the idea is to take or generate seed questions and increase the depth and width of these questions using an evolutionary algorithm. And we also have things under it to also, mechanisms under it to ensure that the questions are of diverse nature. Like, you could see questions that can be only answered using, context from multiple documents. You could see questions that can be answered using, in-depth analysis of, tables, structure, and etc. That's present in these documents. These are the type of questions that usually people encounter in production that are difficult to answer in a simple RAG system. So that's what we intend to do with this framework. And we, as a first step for our evaluation, we generate a test data set using the Casper set of papers. And yeah.
So yeah, after building the data set, so the initial test data generation does give you an initial starting point, but then we have seen that our users have to spend some time manually passing through the the generated one, making sure that it actually matches the ones that you want, and it's and to ensure quality. And so for this RAG, I manually went through the generated one, figured out what is working, what is not, and what I want to keep. And so yeah, that's a groundwork I had to do. And then heading to the notebooks.
Yeah, just an idea on that. So the idea here is not to replace the whole workload of the developer in generating the test data. It's about reducing the load by 90%. The 10% is where you can go through the test generated data and pick or just filter the things that the samples that you don't really think that is fit for your case. Yeah, that's that. Yeah.
Yep. So like I said, we are using the COSPER data set. We for this experiment we take 10 papers from the validation set, and then we use load up the verified test generation data set that we have. And so now we have the data on which we want to build the RAG. We have a golden test data set that we want to evaluate on. So now we are good. So now the first step is to build some sort of baseline. So if you're coming from an ML background, first thing you do is build a baseline. So here we are going to explore two baselines, which is one is very the vanilla Llama index RAG, and the second one is going to be just going to put the question into GPT, because like I said, this is an old question, so probably GPT already knows it. So we'll test that out. So first we just create the RAG system, and then we also create the baseline, and we run a few things to check if it's working. And the first one is, okay, so now you have two baselines. Now you want to see out of these two, which is actually better. So that is when the first metric that we'll be going to be talk about is that comes into play, which is answer correctness, which basically tells you if the answer is correct or not. So here we are going to do, hopefully it works. Yeah, So here it's basically, we are going to evaluate a single response. But before that, Shahul will give you an overview of what actually is happening under the hood to measure answer correctness.
Yeah, could you just okay, let's see. Yeah, so answer correctness. So the idea, the aim here is to compare two answers, right? So generated answer and and the expected answer, which is the ground truth. So how we do the comparison is basically using a simple function as factual similarity between these answers and also the semantic similarity between these answers. So the semantic similarity is, I think, it's clear by its name. You just measure the how these vectors are cosine distance between these text vectors, but the factual similarity is a little more tricky to understand. What we do here is break down these answers into statements. Let's say, any text or any paragraph can be broken down into statements. And when comparing the answers, we then quantify true positives, false positives, and false negatives, comparing the ground truth answer and the generated answer. For example, a true positive in this case will be statements that are present in the ground truth answer and the generated answer. Likewise for the other two measures. And then we use the same, the number on each to calculate the traditional FN score to quantify the factual similarity between answers. And then we go back to the answer correctness, which is basically a weighted mean of factual similarity, which we just calculated, and the semantic similarity. Yeah.
All right. So now we have a metric that we can actually measure, which tells you an end-to-end score of how good the answer for the RAG is. So now we'll run a couple of examples from both the baseline and the other one. Okay. So the first one is from the RAG, and we'll evaluate both. And here I'm actually using a tracer so that you can actually see how the score is actually being computed. Here I'm using Langsmith, but any tool works. And computing score. Yeah. Doing the evaluations. Yep. So here you can see that right off the bat, it gave a higher answer correctness to the LLM's answer, and the RAG answer is not correct according to the metric. So now the question is, okay, why did it actually say that? And to answer that, you actually go on to the whatever tracer library you're using. And here we can see, yeah, shall you want to take this?
Yeah. Can you just expand on?
Yeah.
Yeah, so we are just looking at the traces on how the thing was calculated. As I said, how we calculate the factual similarity is by breaking down the answer into statements and computing true positives, false positives, and false negatives to then use it to compute F1 score. So here, let's say now you can see if it's visible, you can see that the LLM has outputted true positives, false positives, and false negatives. So now comparing this answer, the generated answer, to these statements, we can get the number of true positives, false positives, and false negatives. And by plugging in that number of each into this corresponding formula, we can get the F1 score. This explains how the factual part of it. And then we have also the semantic similarity part of it. Semantic similarity is generally high if the answers are kind of close. So we cannot, fully rely on the relative weight of semantic similarity is 20 to 25%. That's what we keep it in. But the factual similarity has higher weightage. So if you average the semantic similarity plus the number you get from the F1 score, we just calculated using that particular formula and the number of true positives, false negatives, and false positives, we can get to the, we can understand why LLM gave this particular score in this particular instant. Similarly, you could do for this formula is in the docs as well, but you could explain each of these scores for other Ragas metrics also, which we'll cover. Yeah.
So with one single metrics now you can have an end-to-end evaluation of the whole thing. So you plug in like your whole data set, you run it on the entire data set, and you see that you get the final score for which the RAG performs better. So now you get an idea of that. It's okay. It's like GPT doesn't know a lot about the data set, but then it might as well use RAG. So another experiment that we need to do, now we have a RAG, but how do you actually improve it? Like, so for improving it, you can actually improve it in two ways. One, and the most important, is like improving the retriever, because most of the time it's the retriever that gets messed up. So for the retriever, we have two matrices that you want to give a.
That's basically retriever, recall, and precision. Basically, the traditional concept of recall and precision, but something which which we can take a natural language as input.
Yeah. So here we are using so we have the baseline, and for the baseline and for the improved version, we are using Cohere's re-ranker, which gives you slightly better precision. And that's mostly because there's not a lot of diff between here, because we are only using 10 documents, which is a small data set. So there's a small improvement, but not a lot. And then similarly, you can also improve the LLM, and for that we have two matrices.
Yeah, when it comes to LLMs, it's basically how relevant is the answer, and also how faithful is the answer given a ground truth. So the two matrices are general answer relevance and faithfulness, which quantifies the hallucination given a ground truth, given a grounded text.
Yeah. So that is the gist of what we are metrics development according to how we are using the library. If you are building a RAG pipeline, and how you would systematically evaluate and improve a pipeline. So hope you got something from the talk.
Thanks. I think we'll have to take some questions if we have time.
So I have one low-level question, and it's really quick, and one high-level question, which I think is more interesting. But low-level, just to make sense of what you'd gone through, you were showing two metrics. Just so I'm clear, there's precision and recall generated for each of those, right? Correctness and faithfulness. Actually, you obviously have more than two, but there's precision and recall for each of those, right? Okay, cool. That was the only.
Okay.
That was low level. High level. When you use the same model to evaluate itself, generally it's going to like itself more. As I think we've all seen a little bit, it's hard to see at scale, but we just kind of noticed it. How do you account for that? And how would you recommend accounting for that with your package? Can you split it into two models or?
Cool. I guess Shahul is the model expert here. So
thanks. That's it.
Okay, cool. So the question was about the bias from the model, which we use for evaluation and generation. So the idea here is to when it comes to evaluation, the only thing that matters at the end of the day is how much the score is correlated with some human evaluation. Let's say we ran experiments where we had human evaluate certain data sets. We use the same mechanism to evaluate certain data set, and we quantify the Pearson correlation between the two. So generally what we see is that the correlation between these two is generally higher, which is more than 90%. And as LLMs becomes more and more better at these kind of tasks, this correlation will tend to go up as LLMs becomes better. But certainly there is a risk of bias. But the way which we try to solve this bias is, instead of asking the LLM to directly score, let's say LLM has this kind of scoring bias. Let's say if you ask LLM to score something, it most probably give you a score that is integers, not really floats. There is no particular reason for it not giving floats. So instead of asking LLM to score directly, we would design paradigms that could overcome these kind of biases. Here we could see that we are mostly breaking down things into statements and then asking, trying to then, verify the statements and everything instead of just asking the LLM to score it directly. So there are these kind of non-biases of LLMs. What we try to do is design paradigms that overcome these kind of non-biases of LLMs and do the evaluation as effectively as possible, as correlated as possible with human evaluation. Yeah, I hope that answers.
Yeah.
Yeah.
Question around how this approach handles complex queries. So my use case is around insurance, where there's 100-page, 300-page legal documents, which have dependencies between the document. And part of the ground truth is this part of the answer depends on this part of the document and this one, and there can be multiple references. So I'm wondering, does it handle that? Have you approached that at all?
Yeah, again, there is this question about, I think in this case, you might be interested in calculating something like a recall. So this thing comes to also comes to on how which LLM are you using here. If you are using something like a GPT-4 to calculate the metrics, you would get a higher correlation than you would get from a 7 billion model. So that's the underlying thing there. The better the model, the better it performs on long contexts, even though there are some certain issues there. But generally, we are betting on the fact that models will get better at this to a level that it gets to something very close to human evaluation. I don't know if that completely answers your question. You could, yeah. Yeah. Yeah, I mean, soon enough, I think. Yeah, it depends, especially in situations of very long context, like 300 pages, etc. You certainly see issues with evaluation as well when using LLMs, which are not really good at handling longer context data.
I think it's less about long context, more about like
the exactly. So the thing with creating ground truth is that we don't expect you to, first thing is that we don't expect you to create the right chunks to be retrieved. We actually derive all that from the generated, the expected answer. So we never, Ragas does not require a ground truth context. Rather, it only requires, in all cases, it just requires a ground truth answer, which is much easier to create if you are a domain expert. If that's not something that you would want to do, you might want to check out the automated test data generation. So there are the algorithm itself creates questions that can be only answered using multiple documents. So that was one of our main concerns when creating test data, because we need these kind of documents to ideally represent what's happening in production. Yeah.
I have a question on the intent, kind of more broadly, of Ragus. Is it mostly to get those high-level quantitative diagnostics of which model is on average better? Or were you thinking that it would be more diagnostic toward finding and fixing underlying issues? And sorry to ask a really long question. The second part of this is that it seems like mathematically you're kind of doing counts of false positive, false negative, the classic precision recall. How are you handling like the severity of a wrong answer or like a risk related to it in the Ragus model? Like, obviously if you tell someone to like drink cyanide, that's a worse recommendation than like drink bubble bath. Like there could be wrong answers that have different shades of wrongness.
Right. Yeah. So to answer the first question on how, on which level are we trying to operate on, we certainly want to operate on the lower level where people can use Ragas as a framework to optimize their RAGs. If someone want to optimize any ML system, I think we should operate on a low level. And going forward, we'll be looking at general LLM applications for that. But the nature of the solution will be different when it comes to general LLM application. Your second question can be answered. Okay, how I think about it is, so answer correctness is one of the metrics that we showed today, right? So let's say in your case, you would want to also quantify some kind of bias or something in the answer itself. you would want to use a combination of answer correctness or something like, or plus something like harmfulness score or something. So in that way, you would get an average score on the different aspects that you care about. We don't think that one particular aspect or one particular metric can address all the concerns. Rather, we break these into individual metrics and try to address it in an individual way. And the users are free to combine it according to their own best judgment. Yeah. Yes, you can combine the metrics as you are the best judge for it as the domain experts. Yeah, we don't do it. Yeah, sure. Yeah.
I have a question. I wanted to dive a bit deeper into the test data set generation that you mentioned.
Sure.
You mentioned you have a question generator piece. And I was just wondering, I'm guessing you're doing things like multi-op reasoning or like the synthesis of multiple documents for the purpose of answering your question. Like what metrics are you using to actually evaluate whether the questions that you generate are actually decent? Like I know there's things like coverage and what.
Yeah, I mean, you are asking, just to repeat the question, you are asking how we are evaluating the effectiveness of our test data generation piece.
Yeah, specifically the question generation piece.
Yeah, it's something we are also looking at. We haven't yet come up with a solid metrics on how we can quantify the quality of test data, because it's kind of difficult, and the word quality itself, we have to come up with a way that we can objectively define what is quality here, right? So the way which we have seen here is to maybe define it in a way that how much overlap does it have to questions that you see in production. That can be quantified using something like a KL or something. But this is one way, and there can be other ways on how diverse the thing is. All these factors matters. So we are trying to come up with something that that helps. If you have any ideas, love to talk to you after it. Yeah.
Just to continue the same thought on generating the test set generation, you mentioned once you start with a seed test set, you kind of evolve in both breadth and depth of the questions. So can you elaborate a little bit more on like?
Sure. So by default, even if you use GPT-4 to generate a question, given a context, it generally fabricates a question that is vague and that's very specific to the context and very easy to answer. Let's say you have a 500 token chunk and you give that chunk to GPT-4 or any LLM. It mostly follows a very particular style of question generation. I think it's mainly due to the effect on fine tuning, but it particularly follows a kind of style in question generation. Most questions mostly start with what. You don't really see that in production. That doesn't make sense, right? And the depth of the question itself. For example, a question that requires multiple reasoning chain is something which I define as more deep, right? So these kind of the questions which contain these kind of more depth are very low if you use GPT-4 or any LLM naively to generate questions. We are trying to overcome it by generating the initial question, evolving it in a way using certain techniques which are little more time consuming to explain. As of now, we could talk after this, but we are trying to generate these questions. First generate a simple question, evolve it into something which is more deeper, which requires more reasoning, which requires maybe multiple context to answer, which comes with a particular condition or something that is more diverse in nature. So the problem which we are essentially trying to compete here is the naive question generation of using LLMs. We want something better, and I think we can do it using a intelligent flow and algorithm here. Yeah,
All right, thank you. Let's thank our speakers.
Thank you. Yeah, thanks guys. Yeah, thanks for having us. Yeah.
And you guys are hanging out afterwards, so right?
We'll be around
a little bit. Okay, so you can find them afterwards for more questions. I think this lined up really well because Ragus is a great tool while you're developing your AI application. Our next speakers are also our sponsors, Arise, and this tool is really good once you've deployed. So our next speaker is Hakan Tegul. He's an ML solutions engineer at Arise. He's an AI ML specialist. of data science and customer success. He works with ML engineers to detect, troubleshoot, eliminate ML model issues faster with Arise. His talk is Path to Production, LLM System Evaluations and Observability. Where is Hakan? Oh, great. Okay. Thank you.
Okay, got it. Cool. Yeah, first of all, thank you all for coming in. I'm sure some of you might be expecting Jason, our CEO, but he had a thing come up, so I'm filling in for him today. And today we're going to talk about LLM evaluations and actually how to troubleshoot LLM applications in production. So I actually want to start with like this slide where like, I'm sure many of you are building like different Gen AI applications. And even though it's like very easy to like have like a demo ready with a couple lines of LangChain or Llama index code, it's actually not that easy to transition that into a real product where you actually drive business value. So today, like what I want to do is like, how can you actually leverage some open source tools to actually make sure that like this transition is not as hard as it looks like. And to do that, let's actually look at a complicated use case in production. So here we actually have a very kind of, it's growing in popularity in an e-commerce use case. And what we like to call this chat to purchase. So you basically have a user interacting with some sort of chatbot. And then at the end, the goal of the chatbot is to make sure the user actually purchases a product. In this case, it's a travel app. And the user tries to plan a family for his or her summer vacation. So based on that, the chatbot asks some questions and try to give up some responses, some recommendations. So this is actually a very complicated use case that you can do with LLMs. And the reason is that there's actually a lot of stuff going behind the scenes. Like based on users' responses, first a structured extraction occurs where like the chatbot retrieves like the month, possible cities, population, etc. And then from there, a traditional ML or a large language model can work to do like a ranking recommendation model. And then based on that, at the end, LLM provides like a neat response on like what vacation options he can purchase. And if you actually look at this whole workflow, there are a lot of issues that can happen in production. So first of all, when you look at the building blocks, like you might have like a LangChain Llama index agent working, then some LLM to extract the structured parameters, then a ranking recommendation model built behind the scenes. Then you might do like search and retrieval to pick like specific itineraries. And then finally you generate the response. But as you do this full workflow to make sure that the user purchases something, like you might need to troubleshoot different agents or chain that you built with Llama index. You might need to do like prompt testing analysis to make sure that like the output is right or the structured extraction actually works. You need to also consider ranking model metrics when you actually want to kind of do like a metric-driven performance analysis. Or if you're doing like search and retrieval, like a RAG application, you also need to have the ability to troubleshoot that. And then finally, after doing all this, you need to have a way to evaluate this whole interaction first as a whole and also by component to make sure that this actually kind of works. And you actually have a way to monitor these applications, these very complicated applications in production. So based on this use case, right, if you actually want to do this, like do all these steps, you kind of want to use some open source tooling to make sure that like you can observe this application, which is where the concept of LLM observability comes from. So if, based on the example we looked at, if you actually look at the LLM observability space, there are like different categories that you need to kind of leverage in order to make sure that you have full visibility on your application. So the first one is evaluation. How do you actually evaluate an LLM application? That's what I'm going to focus on today. And the second one is like, even if you don't have those evaluation metrics, how do you actually debug those in production? How do you actually trace and find the issue in your application? And even if you can do that, right? How do you do like prompt engineering to make that work? How do you like test your prompts in production? And then if you have like any RAG applications, how do you troubleshoot that in production as well? So these are like some different pillars that you need to consider if you want to go into production. And I'm actually going to focus on the first two today. So let's start with evaluation. So again, like the main question that we're trying to answer is, how do I evaluate my application as a whole and also as component by component? But before I jump into like evaluation itself, like there are a couple of different concepts when it comes to evals. There are model evals and production LLM evals. So I kind of want to make a difference between those two before I actually start talking about LLM evals, because those two are actually kind of different when you try to when you think about evaluation. So let's first quickly talk about model evals. So model evals are basically a way for you to pick a foundational model itself that you're going to use for your application. So these evals are basically leveraged to make sure that, like, okay, for different type of like generalized use cases, the foundation model actually works and fits your use case, and you can actually use that. So it's also used to like create like, as you know, like the OpenLLM leaderboards, etc. But the goal of a model eval is to choose a model itself. So let's look into the other type of evals, which is production LLM evals. So you actually want to use production LLM evals to basically measure performance of specific tasks, specific components in your application. For example, you have an application that does summarization. Well, you want to first evaluate just the summarization task. Then you might want to evaluate your RAG part. You might want to evaluate user frustration. If you're generating code on top of it, you might want to evaluate that. So it's focused on task by task performance measurement of your use cases. And these are some of the evals that our open source library Phoenix provides, but I'll show those in a demo, but just wanted to give some context on production evals. So how do these actually work, right? The production evals. So the idea is actually simple. You actually use another large language model to evaluate your current LLM system under test. Let's say you have your input data coming in and your output data from the LLM system, and you want to take in those data sets and then basically leverage our LIS Phoenix eval library to basically evaluate. So how does this work, right? So you actually have an eval judge LLM, right? So I'm going to call it judge LLM to basically simplify it a bit, where the judge LLM will use the input and output and will use a prompt template and will basically evaluate your system for a specific task. So again, let's deep dive a little bit to see how this works. Okay. So let's say we have a RAG application, right? That retrieves something and then the LLM responds based on the user question. So in the Phoenix library, you first have an eval template, and the task that you're trying to measure the performance on is retrieval. So here we basically use this prompt template to compare if the user question and the reference text are relevant to each other. So like the user question is like, find traditional French recipes, right? And then the reference text gives some like recipe on caramelized onion bread soup. So the eval template is going to basically compare these two and will provide an evaluation whether they're relevant or not. So because we're trying to just focus on retrieval right now. And the judge LLM will be doing that evaluation. So you run the eval template on this LLM to generate an eval. So yeah, before I go into the slide. Okay, so this is a prompt template. This is not hard to write. How do you actually trust this? Like, how do you actually trust that this will work for your use case? This will work for many different applications out there. Well, in order to do that, you need to do some benchmarking. So what we actually do is like we take public data sets online that already have human labeled answers, like right next to like user question and reference text, and that the user answers say whether they're relevant or not. Then we compare our prompt templates performance against those public data sets and human answers to come up with these precision and recall scores. So these precision and recall scores basically tell you that, okay, we benchmark these eval templates, these prompt templates, across a wide range of examples that are humanly labeled. And then we basically say that, okay, this is our performance when you use this like foundational model. So like the actual classes here are basically human answers. And the predicted classes in this confusion matrix is our AI generated answers from our prompt template. Again, we're just doing benchmarking here to make sure that you or me can trust my eval and that prompt template. And then you use precision and recall to quantify these measurements. After these measurements are done, you need to check on like, okay, what you need to do what you need to use, which model you need to use for your judge LLM, right? So like you might have a Q&A correctness eval, you might have a retrieval eval, and like these actually perform different across like different GPT instances or different foundational models. So like if you're using like GPT 2.5 Turbo Instruct as an example, our Q&A eval does not do that great there, but it does great on the retrieval eval, even though it kind of fails on the Q&A eval. So in that case, like if you're actually trying to evaluate something else, you might want to switch foundational models. So this is why the benchmarking is very important when it comes to LLM-assisted evaluations. So let's look at a very quick example on some like RAG evals. So let's say like we're building a chatbot on Arise, our documentation, and the user asks like, do you need a prediction ID for the training set? And based on that, we return like two contexts from our documentation, the vector store. And then we have the relevance eval that basically checks for relevance between user question and context, saying they're relevant. And then the response says like, yes, a prediction ID is required. Then you basically thumbs up on the Q&A eval because that means that the answer is correct, right? So you can apply different evals for like specific interactions and components in the system, and you can find issues related to it. So yeah, so what I said when I started this talk was, how do you evaluate the application, the interaction as a whole, and also how do you evaluate component by component? So this is where the concept of spans and traces comes in. Like here, for example, we have a full chain of retrieval, and that is built on Llama Index or LangChain, and like your Q&A eval says it's wrong answer. So you know that the interaction failed, but you need to find out why, like where actually does this fail, like which component actually made it fail. And there you actually use the different types of evals to find exactly where your application fails. So is it the user frustration eval on the chatbot? No, it's not. Is it the classification eval during structured extraction? Seems like not, but if you actually look at retrieval eval, like let's say that is irrelevant, so then the problem is obviously with your retrieval eval, and that's what makes the Q&A correctness wrong. So this is kind of how the spans and traces come in. And we also have like an open source tooling on Arise Phoenix evals and traces, where we actually have an interface to basically visualize everything that I just said to make sure that you can actually trace down your application and find the issues one by one. So let's look at a quick demo. Let me make this bigger. Okay, I have some time, awesome. Cool, so this is kind of what gets you here. Let me zoom in real quick. Maybe a little more. Okay, cool. So here, first of all, like you have your aggregated metrics like total token usage, latency, your hallucination rate, Q&A correctness rate, and your relevance. So your retrieval metrics here. And here you actually have each interaction, each actually kind of chain or chatbot interaction kind of recorded here in this tracing view. So you have your questions, the output of the LLM, the evaluations, the time, latency, token usage, and the status. So with this tracing and spans view, you have actually very easy visibility on what interactions actually failed. So let's look at one of them as an example, right? So here we have a question on Arise again for the Arise chatbot that we built. And it asks like, do you support IOU for image segmentation? And the output says, yes, we support IOU for image segmentation. But my evaluation says this is incorrect and hallucinated. So something went wrong here, right? My whole component, my whole application failed here. So I want to understand what's going on here. So I click on this query and it's going to actually get me to this page where I actually see what's going on behind the scenes one by one. Like I have my input and output here. Here are the evaluations that run incorrect and hallucinated. And most importantly, it provided an explanation to me why it thinks it's incorrect or hallucinated. So the judge LLM will not only evaluate your input and output, it's going to also try to explain why something is wrong. For example, it says the reference text does not mention anything about IOU, therefore it's incorrect, something like that, right? So then like you can actually go one step further and see what's going on in the retrieval stage. So let's say like you're using Milvus for your vector store and like you're basically retrieving those for your chatbot, and you will immediately get those retrieved documents here. So like here we have a document on object detection models, another document on like types of models Arise supports. And you can see that both of those are evaluated as irrelevant. So the judge LLM said they're not relevant. And they also explain why it's not relevant. Like it says this question is asking about the support for IOU, but it is about object detection, which has nothing to do with IOU. So again, like you can easily find what's wrong with your application to basically understand and use evals to kind of troubleshoot them. And then you can go into embedding, you can go into the LLM step to get like full visibility in your system prompts, prompt templates, etc. So a big question might come up, like how do you actually get to this view? Like how hard it is? Well, we actually have like native Llama index and LangChain support. So if you actually have that, it's just one line of code and you get to this view. But it is also built on top of OpenTelemetry. So you can also like basically send your OpenTelemetry spans to get to this view. So finally, I want to kind of finish my talk on like going into the next step, right? So here, we went into here. Okay, my application was not doing great. And I found out that my retriever is not doing great because it's retrieving wrong documents. How do you troubleshoot this? How do you go to the next step? Well, that's where you actually go to our embedding space analysis. So what you actually see here is, this is basically your embeddings visualized in a three-dimensional space. So here, the blue points I have are my primary points, basically the user questions. And the gray points are basically my corpus data. So again, assuming that you use Milvus as a vector store, these are basically a sample from your vector store and their embeddings visualized in this three-dimensional space on top of user questions. So what does this give you? Right? Let's kind of zoom in. So you actually have all these points, and if you actually hover over a point, like it says, what is Arise's retention policy? It's gonna actually go to the documents, like the retrieve document, it's gonna point to the retrieve documents to see on the embedding space so that you can see like kind of what's going on. Are they close to each other or not? So this gives you a better way to analyze your prompts, the way your retrieval works, etc. So this is just like a more manual visualization of your embeddings, but we don't stop there. We also apply some sort of clustering on top of this to make sure that you find the most problematic segments in your data. So what we do is, like, again, we have a metric here that is our relevancy eval. So I'm using my eval as a metric here. And what I'm doing is I'm actually clustering all these points that are close to each other to a clustering algorithm. And I'm actually sorting them by the lowest metric value. So here, like I have like these clusters as the lowest metric value, and I can click on the cluster to see what's about it. So like this cluster tree has only a 27% on average. That is a relevancy eval rate, like relevance rate. And then this cluster is basically my worst performing cluster. So with this view, you can immediately find the common themes in your application, in your RAG application that fails your interactions. And if you actually look at this cluster, right, you actually see that, like, if you look at the user questions, like, it's all about Arise pricing, like how expensive is Arise? Do you have a pricing? What is the cost of the Arise platform? Well, this all makes sense because we actually do not have any pricing info in our documentation. It's a technical documentation on Arise. We don't do pricing. We only put pricing on our website. So this actually makes sense that this cluster is my worst cluster because I don't even have documentation about it as well. So by using this, again, like you can first find gaps within your vector store and add more context there. So like I know that my user behavior changed and it started asking about Arise pricing. Well, now I guess I need to add Arise pricing to my documentation so that it redirects to my website as an example. So again, by using the traces and spans and this embedding space analysis, you can basically make sure that you troubleshoot your RAG applications in production and find issues as soon as possible and resolve those issues by using open source tools like Arise Phoenix. So that was my talk. Thank you so much for listening. Definitely check out Phoenix. It's open source. Give us a star on GitHub and reach out to me if you have any questions. But yeah, thank you so much.
Thank you, Hakan. Let's see if we have any questions.
First of all, this is amazing. Thank you. I think it's much needed.
Awesome.
And I'm sure you and others have noticed in the news all sorts of like fails with these chatbots. I think the latest one is like some Air Canada that we lawsuit around something.
Yeah.
So I'm wondering, can you run this live in production? I'm thinking here of parallel, you know how like think supermarkets with like self-checkouts, there's still a staff member kind of monitoring that like this thing doesn't screw up. What do you think of like think of a human monitoring a bunch of chats using this tool in real time? Is that something that's a possible use case?
First of all, that's a great question. And Air Canada now uses Arise because of that. But yeah, so to answer your question, we actually have an Arise core platform that is specifically built for production. We actually recommend to use Phoenix when it's actually like not in production, more for pre-production use cases, because again, this actually comes from a notebook. Like what I'm showing right now is just our demo websites, but you actually start this up from a notebook, just pip install Arise Phoenix. But if you want to actually take this to production, that's where our Arise Core SaaS platform comes in, where you can actually basically do everything that you do here on Phoenix, and so much more, like monitoring, getting alerted if something goes wrong, and even more like prompt testing workflows, fine-tuning workflows that I did not get to cover today. But that's where you actually need to kind of invest in some observability platform so that you actually catch those issues in production. But also, if you want to be like, okay, I just want to use Phoenix, we do have the option to deploy like in a Docker environment. You can also see that in our docs. Yeah, exactly. He doesn't work for us, just so you know.
Hey, it sounded like you had about 6 or 7 different types of evaluations.
Yes.
But for some of the questions, I think there were just 2 or 3 evaluations. Are the evaluations like automatically defined, or what's your process behind that?
Sorry, what's the question? Like you have 6 to 7 evaluations, but?
Yeah, like I think there were 6 different ways you could evaluate a model. But for certain questions, I think there were only 2 evaluations that.
Oh, yeah.
So how does that like automatically?
Yeah, that's a great question too. So our Phoenix library also supports custom evals. So let me go into here. Yeah, so you also have the option to build your own evals. Like we actually walk you through the step. What we recommend is like, first you actually build a golden data set. Like again, like I think the Ragas test generation is a good one too. Like we actually use that to benchmark some of the stuff where you actually need some sort of golden data set to actually make this work, right? To actually benchmark it. So you can like pick your own eval. Let's say we don't have PII detection, right? So you want to do a PII detection eval. Then like you actually build a golden data set that actually includes those and like some human answers or like synthetically generated answers. And you actually benchmark your PII detection eval on that to make sure it works. And then we kind of walk you through this step by step here. So short answer, yes, you need to build a custom eval though. And then we keep shipping like new evals like once every month. So hopefully, like if you have a request, post it in our community and we'll consider. I think there's one right there.
You asked a question already.
Okay, never mind.
Sorry if I missed it, but could you describe a little bit more what the Judge LLM is? Is it homegrown or?
Yeah, that's a great question. So let me go back to here, right? So again, we use a Judge LLM to evaluate, but the question was like, what is this, right? So it's actually completely up to you, right? So like, this is why we benchmark stuff. Like if you actually go to one of our evals, like let's just pick one. I'm gonna pick like an easy one. Let's do summarization. Like we present our results on different foundational models. So the choice of what Judge LLM to use to evaluate your prompts and responses is up to you. You can use GPT-4, 4 Turbo, Gemini, and all the other stuff, but you need to kind of look at these precision and recall scores before you do that. Like for example, GPT 3.5 is not great for the summarization eval, but the GPT-4 Turbo is perfect, right? So again, like you need to consider what LLM, like first of all, your organization might be using, if you like stick to one. We also support open source LLMs through Light LLM. So it's kind of up to you. The Judge LLM is completely your choice, but make sure that you benchmark it before you move it into production because you never know it will work. Cool.
That sounded like very good advice. Thank you. Thank you, Hakan. And are you going to stick around later if people want to ask you more questions? As promised, we're going to have a quick spontaneous demo of someone using Milvus.
Thanks. So we are one of the users of Zillow, so we're a very happy customer. And I wanted to tell you about Maxim, which is a legal LLM. I think you're all familiar with simple RAG. You can ask a question like, for example, contract termination, and then you upload a couple of documents and then finds the documents, and then it gives you a document summary and a relevant section, which gives you when the contract should be terminated. But I think the new cool thing that I want to show you is, I mean, this is basically prompt. You do a prompt and you get a response. But one of the things we notice from our customers is that they have like thousands of prompts. So like they want the contract termination, but they also want the description of services or the HTML link. And they keep coming up with new prompts for stuff that they want to find in their contracts. And they want to do it over thousands of contracts. So not just one or two, but like thousands. Like imagine you're doing like a mergers and acquisition and you want to go through all the contracts you have. And so that's what we implemented basically. So you can go through thousands of contracts, prompt engineer, find everything and download it as an Excel spreadsheet and just like do due diligence, do contract negotiation, do M&A. That's where we think the kind of RAG thing is going. So instead of just like one question, doing thousands of questions. And yeah, we use Zillis for that. Thanks.
Thank you. If people want to find out more about your product, how do they do that? Okay. Oh, if people want to find out about your product, do you want to give a little? Yeah.
Questions?
Any questions?
If people want to know more about your product, how do we know more about Maxim?
Well, come hang out with me. I mean, Maxim is also, Maxim.tools is the website.